Here's the video solutions for your practice. Unit 11, data 1 through 14. Number 1, which scatter plot below would be the best representation for the relationship between the weight of a car and its miles per gallon? So the weight of the car is the x-axis, miles per gallon is the y-axis. So we have three types of scatter plots. One with a positive correlation where both the sets of data increase. If one goes up, the other one goes up. And negative correlation where when one goes up, the other one goes down. And then no correlation where there's nothing to do with each other. So if we look at our scatter plots, this has no correlation. This one is a positive. This one is a negative. And basically this is a positive, negative. So this basically is no correlation either. Because there has to be a trend. So let's look now at our two pieces of data. We have weight of a car. So if the weight of the car goes up, what will happen to its miles per gallon? Well, the heavier a car is, the harder it is to make it run, the more fuel it needs. So that will make it go down. Or we can flip it around. If the weight of the car is less, okay, then the car should have more miles per gallon. So the smaller cars get more miles. So in either of these instances, one goes up, one goes down. We know from our previous work that's a negative correlation, which means it's letter B. Number 2, the scatter plot shows a correlation between two sets of data. Which statement is true when the scatter plot is said to have a positive correlation? Well, I just gave you that information. So we know that in a positive correlation, when one goes up, the other one goes up. So the two sets of data increase together. Well, we just said that. So that looks like that's the answer right off the bat. Let's just double check. One data set increases while the other decreases. That's negative, we know. There is no obvious relationship between the data sets. That's no correlation. All values in the data sets are positive. Well, they all would be positive. You can't have like negative weight, negative. I guess you could have negative money and stuff, but they're just talking about this is in the first quadrant. You could have data in the other quadrants as well. Number 3, which of the following is an example of negative correlation? Well, we just said when one goes up, the other one goes down, that's a negative correlation. So, which one of these matches that? Amount of studying. So if that went up, your test score would go up. So that's not a negative correlation, that's a positive. Okay, temperature and number of kids at the pool. So the temperature goes up, obviously it's hot out, the number of kids at the pool should go up. Again, that's a positive. A person's arm length, so as my arm length grows, my leg length should grow. That's called being proportional. So that's positive. So it has to be letter D, but let's double check. Number of people, so if that goes up, slice the pizza per person, well, the more people, the less food you have, that goes down. So that's your negative correlation like it asked. 4, which graph best represents the relationship between a person's hair length and their shoe size? Okay, person's hair length and their shoe size. Well, right off the bat, you should be thinking, what? Because my hair gets longer, my shoe size doesn't change. Doesn't matter. My hair got shorter, my shoe size doesn't change at all. So in this instance, there is no correlation. Okay, how long your hair is has nothing to do with your shoe size. So which one of these has no correlation? That basically has somewhat of a negative. That has a positive. This has a positive. You can see here they're all over the place. There's no trend at all. So that's your no correlation. The table corresponds to which of the following scatter plots? All right, well, instead of actually looking at a certain situation in real life, like height in inches, weight in pounds, we don't know what that's for. But they give us a table. So we see that our table height, as we go down this way, is increasing. 61, 67, or 63, 67, 68, so it's increasing. As we go down this table, 120, 150, it's also increasing. Okay? So by using the numbers here, we know one's increasing, the other increasing. So we know that's a positive correlation, which puts it right there. Letter C. Number 6, the figure is a scatter plot of ordered pairs relating the number of centimeters of rain a city received and the percentage of sunshine. What type of correlation fits the data? Well, we could actually use the words, the number of centimeters of rain, and the percentage of sunshine, or we could even just use the scatter plot. If we go from the trend, we can see that it's a downward to the right, so we know that's a negative correlation. But now, is it strong or weak? Okay, so we know it's not a strong positive or a weak positive. Okay, we know it's negative. So it's strong, there is no correlation. Well, they don't even give us a chance to get a weak one, so that one's not right either. Remember, we know weak is when it's kind of flat, like that. Those would be weak correlations, just a little bit down to the right. We already got our answer. The more rain, the less sunshine, obviously. 7, which of the following statements imply a positive correlation? All right, so both have to be going up. The more I practice typing, okay, the faster I can type. Well, that's true. More practice, more words. So that's positive. So we know 1 is true. The more I study, so if that goes up, the better my grades. Well, that's true. Okay, so that's positive. The more I exercise, so the more minutes I exercise, the less stress. No, we know from medicine that if I exercise, I have less stress. If I wanted this to be a positive force, it should be more. So in this case, this goes down. So that's a negative. So 1 and 2 are my positives, which makes the answer D. Which of the following graphs show a line that best fits the data? So we know that you have to start and end with the trend of the data, and you want about the same number of points to be above and below. So here I'm starting here at the beginning and I'm ending here at the end, and I have like 1, 2, 3, 4 above, 1, 2, 3, 4 below, so this looks positive. B. Okay, again, I'm starting at the beginning trend, I'm ending at the end. I have 1, 2, 3, 4, 5 above, kind of 3 below. So this is close, but it's not as good as A, so we know that's not right. Letter C, automatically we see almost all the points are below, so that's not a line of best fit. And D obviously isn't, they're all above, so A is our best fit. Number 9, which of the following describes a line of best fit for a set of data points? Okay, the line should follow the tendency of the data, first to last point. Okay, I just got done saying that? Yes, so 1 is true. There should be about as many points above the line as below the line. Yep, just got done saying that. The points at each end are concentrated on one side of the line. No, we don't want that. And most of the points are above the line. No, that's contradictory to 2. So 1 and 2 are what make a best fit. So that's letter B. C. Chetna grabbed the data she collected from her chemistry class and then needed to find the line of best fit. If the data and line are on the graph below, what is the equation of her line of best fit? Well, we know that the equation can be put in slope-intercept form, y equals mx plus b. Okay, the easiest point to find is the y-intercept right now, which is right there at 0. So we're not going to have a y-intercept, plus 0 or nothing. So now we use our slope. We know our slope goes from one point to another point that we can identify, and it's rise over 1. So up 1, over 3, up 1, over 3. So my slope is 1/3 x. So I have y equals 1/3 x plus 0, or y equals just 1/3 x. And we can see that's letter B. 11. The graph shows the change in price per gallon of gasoline over the past 6 months. If the pattern continues, about how much should you expect to pay to fill up your car's 10-gallon tank during the 7th month? All right, well, here's my 7th month right there. So here's my line. So somewhere in there is going to be my point. So I got to find my line of best fit. So I start over here at the beginning of my data, and I'll end at the last part. So something like Got a few below, a few above. And you can see that most are on the line. So my point is right here. Okay? So that's about $2.75 is how much I'm paying that 7th month. Well, it's a 10-gallon tank. So 275 times 10 gallons, all right, is about $27.50. And that makes sense. Of course, gas is almost $4 now. 12, Chris is hiking down a mountain. The scatter plot shows her elevation at the end of each hour of her hike. Using this information, what is the best prediction of her elevation after hiking 10 hours? So we're going to find our line of best fit. Okay, so we start at the beginning of the data, and it almost makes it pretty close to a real line. And then we're going to extend that out. So I got a little bit above, a little bit below, somewhere right about there. So the 10th hour would be here, and then find your y, so somewhere over there. So we're looking at about 200. That answer is there. 13. The study was conducted to determine whether large or small businesses are located near mass transit. Businesses with more than 250 employees are classified as large. The table shows the results of the study. Of the businesses located near mass transit, what percent are classified as large? The first thing we know to do is to find our totals, just so we understand the graph. Okay, so again, this is called a frequency table. So, how many large businesses were surveyed? So I have 65 and 5, so there's 70 large businesses that were surveyed. How many small businesses? 20 and 10. So a total of 100 businesses were surveyed. Okay, of those 100 businesses that were surveyed, if we do mass transit, 85 of them were mass transit, and no mass transit was 15. And you'll notice 85 and 15 gives us our 100 there. These have to be equal. So now we use our words. What are they actually asking us to check? Of the businesses located near mass transit. So I'm only using this column right here. What percent are classified as large? Well, here's our large businesses that use mass transit. So I have 65 large businesses, and there were a total of 85 mass transit workers. That's why it's important to get these totals at the beginning. So 65 out of 85 will give you your answer C, which is about 65%. The study was conducted of 150 schools to determine if the school has a track and if the school has a swimming pool. The table shows the results of the survey. Of the schools that have a track, what percent do not have a swimming pool? So let's get our totals. So first of all, how many schools have a track? 30 and 90 is 120. How many schools don't have a track? 12 and 18 is 30. And there's your 150 totals. Okay. Of the schools that were surveyed, how many have a pool? 30 and 12 is 42. How many don't have a pool? 90 and 18 is 108. If you add up those two, again, there's your 150. So, of the schools that have a track, so we're concentrating only on these schools right here. What percent do not have a swimming pool? Well, there's your no pool number right there. 90, okay? Those schools don't have a swimming pool, so that's 90 out of 120 that have a track. So 90 out of 120 right down here. So 75% of the schools, okay, that have a track don't have a pool. Pools aren't very likely. So hopefully these two practices will help you for the test on Friday.